Yep. All right. So basically, everyone else did the work for me. I get to piggyback and show you a fun movie. So, um, what we're looking at here is the moment or the wave packet and how the concept of waves. And we want to look at two different waves and how they interact side by side. And MATLAB gives us the ability to show these through code and to run it. So from the basics, we see showing it there is an equation, and we can also see the waves are superimposed, which are at different frequencies, which is why we see the difference in them. So basically, we're going to run the code, that long code that we were given. So we can insert the code into MATLAB and run it, and we can see the position of these. We're going to start with the real, as was said before. We can start with the real image, and basically what's going to happen is that we can see it that once we press the space bar, we are going to see the momentum operator function. And so we can see different variations of these waves dependent on their momentum, and we can change those momentum. So we can see at our momentum on the top at 0.25, and we can see how those waves are kind of coming closer together. As where you put the momentum as 0, they're going to go like they're not coming as close together, but they're going to be farther off in the distance of that momentum. Again, I'm no genius at MATLAB, but looking at these loops, we can see how we can continue the video and show that the momentum is increasing. And these loops look something like this. Both these are examples of what we are using in our codes. So to view the movie, we're again pressing the space bar, and the momentum is going to continue, as we all know, the long momentum. And then at the end, we are given these values of these observatives that are the position and what we can expect to see from the momentum. And then we get to upload to YouTube so everyone can see what we're doing. So basically, you're going to open the YouTube up online. You're just going to hit create. You can upload your file as an MP4. And once you do that, you can make a title, make sure it's not for kids. I don't know why, but they can't see MATLAB yet. So we're going to press that, no kids, and then you put a title, obviously by the best professor ever sent us the code. And then we are going to upload it to YouTube, and it's going to look something like this. Well, do you want me to go out and click on the video?
If you navigate to the bottom of your from the bottom of this white panel with image.
This one? Oh. Oh, there we go. And we're slowly watching the momentum increase. So very intriguing, slowly going. All right, so we can see that, and we can observe what is actually going on here. Let's see. And once again, it is important to showcase what we're doing so everyone can see it. Our quantum idea can observe the wave packets and gain knowledge from what these waves are producing. Yep.
Okay, please join me. Thank you, Allison. Questions to her. I know we are almost out of time, but I have two questions.
Okay.
So, can you scroll to slide number 5? And the question is to everyone. 5 backwards. Yeah, stop here.
Okay.
So, what if anyone has answer, please raise hand or just shroud from the place. What is on the y-axis? It shows probability, but probability of what? And it is kind of advanced question because we didn't cover it in the labs. So what are you showing for momentum of 0.25 and momentum 0. What are these lines that start at 0 and 1 and then intersect?
Is that the frequency?
No.
No.
So if anyone has even a rough idea, please do not hesitate. Wait.
Probability of density.
Repeat.
The probability of density.
Probability density. Well, maybe just probability, but probability of what? Any ideas? I will give the key in a minute, but please focus on it. We will need it for projects. So something that happens more vividly if we increase the temperature, the momentum. How do you connect it to the chemical reactions? Like if you, yes, so it's probability to form a product of reaction. As reaction goes by, probability to find a product grows from 0 to like 20% or 50% or goes completely. Make sense? Okay, and question number 2, go forward, couple of slides. Stop. So it's a very tricky question. If you do not answer, I'm completely do not mind. So let's look on the lower right. You see the panel is labeled as sigma sub x, and it shows dramatic peaks that appear again and again. So anyone can interpret what are those peaks. Like the width of the wave packet should grow quadratically, and here it grows and then drops. The best person to ask to answer it based on today's presentation is Adam. But question is, do you, Allison, if you have any ideas, please try. And help is appreciated, especially from Adam.
Thinking. I haven't got any ideas.
So what did Adam taught us?
Thinking.
What was with
The tricks.
Tricks, and the second part?
The second part.
Passing through the borders, boundary conditions. So what happens if the first half of the wave packet passes through the border and second did not? It looks like it is extended over the size of the box, and it is an artifact of the method. The width of the wave packet for the very short time looks like huge, like 100 or size of the box, and then when it completely passes through, it becomes small again. Make sense?
Yep.
I was fearing this question for many years. Okay, more questions to Allison. If no, let's thank her once again.